Welcome to Beekeeping Today podcast presented by Bee Culture. Beekeeping Today podcast is your source for beekeeping news, information, and entertainment. I'm Jeff Ott.
And I'm Kim Flatham.
Hey, Jeff and Kim. Today's sponsor is Global Patties. They're a family-operated business that manufactures protein supplement patties for honeybees. It's a good time to think about honeybee nutrition. Feeding your hives protein supplement patties will ensure that they produce strong and healthy colonies by increasing brood production and overall honey flow. Now is a great time to consider what type of patty is right for your area and your honeybees. Global offers a variety of standard patties as well as custom patties to meet your needs. No matter where you are, Global is ready to serve you out of their manufacturing plants in Airdrie, Alberta, and in Butte, Montana, or from distribution depots across the continent. Visit them today at www.globalpatties.com.
Thanks, Sherry, and thank you, Global Patties. You know, each week we get to talk about how much we appreciate our sponsor support, and we know you'd rather we get right to talking about beekeeping. However, our great sponsors are critical to help making all of this happen. From the transcripts, the hosting fees, the software, the hardware, the microphones, the subscriptions, the recorders, they enable each episode. So with that, thanks to Bee Culture Magazine for continuing their presenting sponsorship of this podcast. Bee Culture has been the magazine for American beekeeping since 1873. Subscribe to Bee Culture today. Hey everybody, thanks for joining us. We're really happy you're here. Before we get started, just a quick reminder to subscribe or follow Beekeeping Today podcast and give us a 5-star rating. It really does help. Also, we are now adding complete transcripts of each episode on the website after the show notes. Check them out. You can also leave questions and comments online under each show. You can leave a comment, ask a question, reply to a question, ours or our listeners. Click on Leave a Comment at the top of the episode's show notes to join the discussion. Have you listened to an episode and thought, that person sounds really interesting, and I'd like to know more about them? Well, now you can. Each episode links to a guest profile. Each profile has a guest photo, bio, contact information, including Instagram and Twitter details if they have them. Check it out. And finally, share the podcast with your beekeeping friends, email them links, or mention it at your next beekeeper meeting. Hey everybody, thanks again for joining us. We are glad you are listening because today we have another great show for you. A couple of weeks ago, we talked with 2 of the 4 Project Apis M CostCo USA Scholarship winners, Audrey Parrish and Chris Robinson. If you haven't listened to that August 29th episode, I suggest you do because of the exciting research those 2 are doing. This week, we introduce you to 2 of the other scholarship winners for 2022, Angela Encerrado and Rogan Tokash. Angela is here to talk about her research on a fungicide and pesticide commonly used in almond orchards on honeybee health, and Rogan talks about his research on the effects of pesticide contaminants on worker bee behavior. Also joining us this week is the Executive Director of Project Apis M, Danielle Downey. She's here to talk about the scholarship program and the other great work Project Apis M is doing for the honeybees and for the beekeepers. We are so inspired by the young minds at the beginning of their bee research careers. It gives us hope for the future and belief that ultimately these environmental challenges will be resolved. Speaking of challenges, do you know your mite count? When was the last time you actually did a mite count? It is October. If you don't know and you haven't treated, it is very likely your bees will have a very rough go of it this winter, no matter what part of the country you live in. If you don't know your mite count, if you've never taken a sample, I encourage you to find a beekeeper who has and ask for their assistance, or check out the fantastic resources on the Honeybee Health Coalition's website on testing and treatment options for your bees, whether you want to treat using natural or synthetic chemicals. We have all of that coming up, but first, a quick word from our friends at Strong Microbials.
Hey, beekeepers! Many times during the year, honeybees encounter scarcity of floral sources. As good beekeepers, we feed our bees artificial diets of protein and carbohydrates to keep them going during those stressful times. What is missing, though, are key components. The good microbes necessary for a bee to digest the food and convert it into metabolic energy. Only Super DFM honeybee by strong microbials can provide the necessary microbes to optimally convert the artificial diet into energy necessary for improving longevity, reproduction, immunity, and much more. Super DFM Honeybee is an all-natural probiotic supplement for your honeybees. Find it at strongmicrobials.com or at fine bee supply stores everywhere.
And while you are at the Strong Microbial site, make sure you click on and subscribe to The Hive, their regular newsletter full of interesting beekeeping facts and product updates. Hey everybody, welcome back. Sitting with us at the virtual Zoom podcast table are two more of this year's Project APSM CostCo Scholarship Award winners, Angela Encerrado and Rogan Tokash. And this week we are joined by the Executive Director of PAm, Danielle Downey. Welcome, everyone, to Beekeeping Today podcast, and I must say congratulations on your scholarships.
Thanks, Jeff.
Well, it's nice to get a chance to meet all of you in person.
So thanks for joining us. The reason we're talking to you, as we talked about a couple weeks ago, was the PAm CostCo Scholarship Award program, and Danielle had brought us a couple different guests last time, and this time Danielle's going to join us to talk to us a little bit about the scholarship program. So Danielle, give us some background information on the scholarship.
Sure. So Project APSM is an organization that began back in CCD days, so in about 2006, 2007, and it came together with beekeepers and growers and researchers to fund research that is applied. So beekeepers didn't want to wait for the USDA or university labs to do work that might be relevant. They put in their own money and said, we want these projects to happen right now. And PAM does that and has become a vehicle to support research. This year, we're going to pass $10 million in research funded, which is a pretty huge milestone for a small nonprofit. So we're excited about that. And one of the fun programs that has come out of some of our sponsorships with CostCo is a legacy program to invest in the scientists to solve the bee problems of tomorrow. So we need good scientists, and supporting graduate students is a good way to get these students on track to interface with industry and get on projects that are relevant and get them speaking the language of beekeeping as they learn their research. And they're really excited about their work. They're always an excellent investment, and it's always really fun to get to know them and see their projects taking off. So we have supported now over $1.3 million worth of scholars, and that's 21 students. And many of them go on to start bee labs of their own. And so it's really exciting to get to hear from Rogan and Angela today as they're just starting their bee research careers.
A couple of weeks ago, I mentioned we had Audrey and Chris on, and I encourage our listeners, if you haven't heard that episode of Beekeeping Today podcast, you go back and call that up after you listen to this episode.
Yeah, so Audrey and Chris and Angela and Rogan are the scholars that we have just selected in the U.S. this year. We also selected a couple in Canada. So we've got 7 scholars in Canada that we've supported, and then the rest of them are in the U.S.
And this is all on bee research.
Yes. So the students are selected based on their project in honeybee research.
I think you fairly well categorize it as applied research. This is information that beekeepers can use an hour from now, almost. I mean, that quick, it can be applied, right?
You know, there's a whole spectrum of research, and research is a long game. Science is not fast, but certainly when we look at projects, we can gauge if it has the potential to be an applied value. And some of them are science for its own sake, and we benefit from that, but it's just a building block that's a lot further away from the end user benefiting. So researchers have a broad spectrum of research. Some labs just carve out their most applied piece and send that proposal to PAM because they know that's what we're interested in. So we're for all the science, but we want to make sure that our dollars are invested in something that could really deliver for beekeepers.
It sounds wonderful, to be perfectly honest. It is, because we need all the help we can get out here. And the more people we can get that know more than we do working for us, the better off we're all going to be. So you've got 2 more people here today that have passed that goal. and you've seen fit to reward them for their work and what they found. So why don't you introduce them and tell us a little bit about what they do, and then we'll let them tell us the rest.
Rogan is a recipient of 2 PAM scholarships. So when the original founding executive director of PAM, Christy Heinz, passed away, there was a lot of support for her legacy, and they showed that by donating to PAM and supporting student scholarships in her honor, which is really great. So Rogan was the recipient of a Christy Heinz Memorial Award, and now he's also continued and applied for a CostCo Award and gotten that. And Angela is a CostCo awardee, and he's in Nebraska and she's in California. They both have pretty long and interesting histories with honeybees to talk about. They're very passionate about bees. So I think we should hear from them and let them introduce themselves.
So I am originally from a small town called Juarez, Mexico. It's a border town with El Paso, Texas, if you don't know it. My history with bees goes back to my dad. We have a bee farm at the outsides of the city, and he was pioneer beekeeper on that region because it's a desert. So there's not really a lot of beekeeping happening. Most of the hives we get come from actually escaping the US into Mexico. So he would relocate them from trees or houses into our hive or like our farm in the outside. And that's how it started. And my background is mostly on chemistry and analytical chemistry, but I wanted to do something more applied. And I wanted to merge my dad's passion and my passion, which was more like science, chemistry, into this project in my PhD. So joining UC Davis has helped me do this. And now CostCo has rewarded me with this. And I'm very grateful for this opportunity. As an international, I'm very happy about it.
First, I want to just say thank you for having me on. So my beekeeping, I'm originally from Abilene, Kansas. And so I actually got started in beekeeping when I was about 12 years old. A local beekeeper brought an observation hive to our just county fair. And I was fascinated with the bees. I thought it was the coolest thing ever. I went back every single day and I always tried to find the queen. I'm a very competitive person, so I made it into a game with myself and I had to find the queen. And after that, I just told my mom that I wanted to become a beekeeper. And she didn't really buy it too much. You know, it's a 12-year-old. Of course, he wants to have new hobbies. So she actually bought me the book, Beekeeping for Dummies, and told me if I read it cover to cover, then she'd know I was serious, thinking that, oh, it's a $20 book and then I won't have to do anything with bees ever again. But I actually did read it. And so then we applied for a scholarship through the Kansas Honey Producers Association. And my family, my sister and I were both awarded 2 different colonies that we kind of started with. So I've been beekeeping ever since. Kind of in high school, I decided that I wanted to do honeybee research as a future because it was a real big passion of mine. So during college, I did internships at the USGS up in Jamestown. And then I went back up to Jamestown and actually worked with a commercial beekeeper to gain some aspects of that side of the business, which I found very fascinating, very interesting. And then I started my master's project here at UNL, University of Nebraska-Lincoln. And then I'm very fortunate to be able to be continuing on with my journey in honeybee research. And I'll be moving to Auburn to start a PhD starting in January.
Howland will be glad to hear that you got your start with his book, I'm sure. Rogan, take it from the top. What are you going to be studying in your PhD, and what background did you have to get you there?
I originally started out as a hobby beekeeper, as I just kind of labeled out, but I also have some commercial interests. And here at UNL, I'm under the advisement of Dr. Judy Wu Smart and Dr. Autumn Smart. And right now I'm looking at kind of some pesticidal impacts on honeybees, because we had a point source pollution spot that Project APISM has been very kind in donating a lot of money to support some of that research that Dr. Woosmart is doing up there. But we had an ethanol plant that was processing some expired treated seed, and all of our colonies in the surrounding area were experiencing 100% colony failure. And this was a site that they had kept bees at previous to Dr. Woosmart's term, kept bees at for over 30 years and no problem. And then this ethanol plant started processing this expired treated seed. So we were seeing very high levels of neonicotinoids in the region. And so my research right now kind of looks at some of those environmental impacts, both keeping bees there and seeing the effect on the behavior, but also seeing what happens when you reuse those resources from those dead outs and seeing the impact on colony functions on things such as queen rearing that you'll be seeing. And so that's what I've kind of been doing for my master's project, which I'm planning to finish up here in November and graduate in December. And then I'll be moving down to Auburn in January, and I'll be starting at Dr. Jeff Williams' lab. He runs the bee lab down at Auburn University. And I'll be doing some more varroa mite intensified research. And so one of the things I'm really excited for down there is that they have the ability, they have a lot of colonies, so they have ability to do commercial kind of level research on varroa mites. So one of the things I'll be doing is potentially looking at some amitraz resistance with varroa mites, and then looking at if we are seeing amitraz resistance, which we are potentially seeing that more and more, as that is, the most common treatment that commercial beekeepers use, kind of seeing how we can get rid of that amitraz resistance if we are seeing it. And so I haven't ironed out all the exact studies that I'll be doing down there, but I'm really excited to get down there, and kind of that's what my baseline level is for my PhD project.
You bring up a good question on what you're doing right now with imidacloprid and all of those chemicals. Has your work done anything to reduce that exposure to the bees in that area?
What our research has kind of shown, and we're showing all these colony losses, is we actually got the ethanol plant shut down. And so that is no longer a problem. But right now, we're still seeing that from that point source contamination, it was in business for 4 or 5 years. And so if you look up Alt-N ethanol plant, you'll immediately see it comes up in Meade, Nebraska. And so now this is a problem that we're trying to educate other beekeepers on, especially in the Midwest, because we don't want this kind of ethanol or this expired treated seed to be sent to any other ethanol plants in anywhere, even in the US or around the world. Because as you saw with our area around Nebraska, is you see huge devastating impacts on wildlife and surrounding area. And so we're trying to make sure and make people aware that with this expired treated seed, if you're processing it in your area, then it's most likely going to have a detrimental impact, not just to the honeybees, but also to the native bees and other wildlife.
And people, I would guess.
Kim, if you haven't heard about this incident, which I'm guessing you have, it is an egregious disaster. The seed was not handled the way that it should have been. So this was a really bad scenario that should never happen again. So remediation is underway. And I think the process of discovery that Judy has gone through and trying to get attention on this has built a consortium of scientists, interdisciplinary scientists, and she's gotten the attention of politicians who have made legislative actions to close any kind of loophole and make sure this never happens again. So beyond the research on how it's affecting the honeybees, there's a whole environmental attention that's being paid to this now that she's working on this project.
I'm curious about the rest of the residue that's out there and how long that will, because this stuff lasts quite a while in the environment. It's a good thing you got it stopped. I hope that something can be done to at least clean it up. So it's a good first step for what you've done, Rogan. And the varroa thing and amitraz resistance, that is as big a problem, I think, almost for beekeepers, because without amitraz, people begin to kind of go in a whole bunch of different directions and aren't sure exactly what they're doing or how well it should be working. So you're going to be looking at the genetics of resistance?
I'll be looking at actual in-hive resistance, but we're also working in coordination with Dr. Rinkovich's lab for the USDA down in Baton Rouge. And so when we do see resistant mites, then we'll be sending those resistant mite populations and the susceptible mite populations to him. And then he actually does a lot of the molecular work with those varroa mites that we get.
And we've had Dr. Rinkovich on the show in the past. Hey, this is a great opportunity to take a quick break to hear from our sponsor, Better Bee.
Hey, podcast listeners, here's what we've been waiting for all year long. It's time to harvest and extract the honey. When you're ready to bottle and sell your crop, head over to betterbee.com. There you can shop for custom honey labels and glass or plastic honey containers. As your partners in better beekeeping, Better Bee does all the work of figuring out the weight each honey container will hold, not just the standard water weight or volume measure. So you can choose from the classics or go bold and different with a great selection of uniquely designed bottles. Check out our 50-plus container options and order with confidence at betterbee.com.
So, Angela, your work at UC Davis in the middle of all the almond fields and almond pollination, and I bet your research has something to do with that.
Yes, you guessed correctly. Well, almond is like the main thing happening in California, and it brings business to both beekeepers and farmers. It was just ideal for us to kind of migrate our research focus in there. We do, however, in the future, at least the lab that I'm working in, maybe not me, but another PhD student, we want to expand into other chemicals, like in-hive medicines, and we also want to go into water pollutants because of this synergistic effect that have been talked about in literature a lot, like the mixture of two, like a fungicide and a pesticide, and how they can increase the toxicity of one or the other. That's what we want to focus, or the lab that I'm working in wants to focus on figuring out what is guiding the synergistic effects. And you have to expand to other chemicals outside only pesticides. But at least for me, in my PhD, I am going only for almonds, and I'm going only for almond pesticide related. And as I mentioned to you before, I'm working on this huge table that's going to have all that information. And hopefully in the near future, we'll have a publication talking about all the synergistic effects, and I'll share it with you. But yeah.
The table that you're working on would be a great cross-reference for any beekeeper. It sounds fabulous. Talk a little bit about the research you're currently doing, the paper that you submitted for the scholarship program.
We're working in collaboration. My PI, his name is Nicholas. He's at the Environmental Toxicology Department here at Davis, and we're collaborating with Julia Fine from USDA. I believe she was in your podcast many episodes ago. And in conjunction with that, we're trying to partner up with LLNL, Lawrence Livermore National Laboratory. And the idea is that we each have expertise on like the biological side, microbiome with this lab with my PI. And then Julia has a lot of expertise on honeybees and queen-nurse relationship, and we want to explore that. And Lawrence Livermore has this capability that would allow us to trace pesticides through a colony using isotopic labeled compounds, which is just like a fancy chemical that we could search for it in the smallest of tissues, because the idea of the research is that at this point, we can see that if we give this much of a chemical to a bee, it's going to die. And we can detect it in the sources, like in the bee bread, we can detect it on the nectar, we can detect it on the wax, but it's not 100% of the chemical that we can detect there. And part of it is being lost within the hive structure. So we want to find these like small places where it's being lost, and we want to see if we can detect the members of the colony which are like at more risk, or like that are being kind of giving all these pollutants. Yeah, so kind of find the nexus within it.
When you start talking about synergistic effects, it becomes very complicated very fast. And are you looking at only at the ingested chemicals? Or are you also looking at the proximity of the chemicals to, say, that embedded in the wax? And so the wax is, the queens are raised in the contaminated wax, and the impact on, say, any of the brood that's being raised in that cell.
So I can tell you that right now, the experiments we're doing, everything's ingested. It's easier for us to control it that way, to look at one individual effect at a time. But the idea it is, like if we can find this chemical in the hive, then it means that it's affecting the bees, right? So the idea is to kind of cross these tables of all these papers that are out there that says, all these chemicals have been found in wax and all these chemicals have been found in honey. So if we can find them there, then we can for sure be certain that the bees are going to be exposed to them. So we can kind of target those exposures and put them in a more controlled environment in the lab and just look at them individually.
Angela, I have a quick question relative to how this works. When a chemical is applied to a hive, and later people test the wax and they find the chemical in the wax, When that chemical is in the wax, I suppose it has to do with what chemical it is, but when that chemical is in the wax, is it released from the wax so the bees come back into contact with it? How does the contamination work such that it affects bees, or does it affect bees?
The idea that we have is mostly that not all the chemical is going to end up in the wax, right? Some of the chemical might still be in the bees in specific tissues. And also when it's in the wax, it's in contact, like it's not skin, but like, surface contact with the larvae, for example. So we also want to see how these chemicals would affect the larvae. And you don't have only one chemical in the wax, you have multiple of them. So if multiple of them are going into, like, in contact with the larvae, like, which is pretty delicate stage of life. Even in humans, the babies are the most delicate, right? This is the idea of the chemicals are like there.
One of the things that beekeepers do most of the time is recycle the wax in their frames, and they get rid of it. I always wonder where it goes. But for that very reason is that we've been told that this stuff has got some level of contamination, whether it either environmental toxins or beekeeper-applied toxins or agriculture pesticides, and it begins to build up. So what you're saying is that it builds up in there because a bee went out and visited a flower that had some of it applied, came back to the hive, walked around the hive, rubbed some of the chemical off, it was absorbed into the wax, and then it stays there to contaminate honey that's in there, to damage larvae that are raised in the cells, and to get onto adult bees?
You mean like how it goes like from the field into the wax?
Right.
Oh, I would say I'm not 100% knowledgeable of it, but from my limited chemical background, most chemicals, pesticides, love fat spaces. Anything that they like to be around, they're going to go to it. So wax is one of those fat spaces that they like to be around. So we would be looking at wax more as a disposed mechanism, like a self-defense mechanism of the bee to like release these toxins, but not all the toxins are going to get released. So that's how I look at it. Still, I don't know that much about it. I still need to read a lot of papers, but yes.
So you're saying the wax is a sink for chemistry?
Yeah.
That sink continues to accumulate, but is it released back into the in-hive environment?
That's a great question that we would like to address. The idea of the labeling is that you have this like a flag or like a tag that you put on the chemical, and then you can just trace it. You can just follow it through the whole hive. We can analyze the wax. We could analyze, the bee bread, the propolis, and we could see how much of the chemical is ending up in there. And we can kind of make the story from the end of the source back to our original chemical.
Angela, is it quantitative?
Yes. The idea is to be do both quantitative and qualitative. With my background is analytical chemistry, so that's where I'm coming from with like, I want to know what is in there and how much of it, because the chemical sometimes not going to stay the same form. Sometimes it's going to break apart. Some of them are not that stable. Some of them are. Propiconazole, which is a fungicide we work with, it has metabolites that can be detected through the beehive. And metabolites is just a fancy way of saying the molecule is broken, the chemical is in pieces, and is traveling different spaces.
This just gets more and more complicated, doesn't it?
Yeah.
Oh.
Well, I'm glad somebody's looking at it, because I've got to believe that chemicals that are in there, whether they're absorbed into the wax or they've metabolized and broken down and they're still in there someplace, has got to be not as good as not having any there at all. So I guess the next big question is, how do we get rid of them? And can we get rid of them, or are we going to continue to throw beeswax away every 3 years because we can't get rid of them?
That's one of our main questions working with Julia. So part of our other theory of where these chemicals go, it's queen bees, because they're being fed this food that's coming from the fields, and it's just polluted, right? So is there a defense mechanism within queens that is like releasing those chemicals through larvae, because larvae is a fat tissue? So chemicals like to go with fat. They might go in there. And in this case, do we really have to be switching queens so often? Is this really a necessity? And that's our kind of our area with Julia, part of the research we're doing with her.
And I'll just jump in here and say that was one of the other scholarship award winners. Research was on the effects of the chemicals on the queen larvae. And I think that's Audrey Parrish's research was focused on that. Or it might have been Chris Robinson. I don't remember. One of the two. Check out that episode.
When you're looking at resistance to Varroa, I'm going to guess that part of your work is going to involve applying some kinds of pesticides to the hive, to the bees, something. How do you sort out the result of what Angela's looking at here, contaminated wax? Does that enter into what you're doing at all when it comes to Varroa resistance? Because if you've got contaminated wax, I'm sure you've got bees that are stressed at another level and may not be able to exhibit really resistant traits. Am I anywhere close here?
Yeah, so that's what makes beekeeping so difficult sometimes is you have all these different factors in the hive. You have your varroa mites, you have your pesticides that could be potentially damaging your colonies. So I'm going to be looking at varroa mite resistance to amitraz specifically. And so we'll be looking at, there's a test that's been developed, where we have bees and we place them in a cup with a apivar strip. And then we see how many mite drops, we get from however many bees. And then we categorize and then we do an alcohol wash with the bees that are left in that cup. And then we see how many mites get dropped after the alcohol wash. And then obviously if there's a lot of mites in the alcohol wash and there's not that many that dropped out from the apivar strip, then you're seeing that you have pretty resistant mites and you don't have that great of efficacy with your apivar strips or your amitraz treatment. And so that's mainly what we'll be doing. And this is a project that has already kind of been started down at Auburn, and Dr. Rinkovich has already done quite a bit of work, as has Dr. Williams down there and Dan Arell, who's a current PhD student. And so they've been doing quite a bit of sampling in the southeast, but also up in the north and the northeast, kind of looking at potential with commercial beekeepers and looking at the commercial beekeepers and those amitraz resistance. And so that's a paper that I think they're looking to publish pretty early next year, hopefully. And so I'm going to be kind of joining in on some of that research, really looking at the resistance of varroa mites. And then if we do see resistance in those yards, then what are some of those measures that we can take to kind of potentially break that resistance? Is it maybe just an oxalic acid dribble, when they're in a cluster late in this winter season? Or do we have to go further to really break those resistance mechanisms that the varroa mites are showing to then get rid of that amitraz resistance within those varroa mite populations?
You bring up an interesting test here that I hadn't thought of before, but I'm wondering if beekeepers should be considering. When you double test the amitraz, you put bees in a jar, you put a strip in, you shake it up a little bit, wait some period of time, and then pour the bees out and see how many mites were dislodged. And then you do the alcohol wash on the bees again and see how many bees again you find. So the more bees you find the first time, the better. The more bees you find the second time, not nearly as good. Should beekeepers be doing this?
I think a lot of beekeepers honestly do this on their own because they'll do mite treatments or mite tests with their bees before they even do mite treatments. And then they'll do mite tests after they do mite treatments. Essentially, all we're seeing is how quality was the mite treatment. Did the mite treatment even work? And I think beekeepers do that a lot because obviously they're trying to get a pretty quick knockdown with some of the different methods that they use on these mites. And so what most of the time they're doing is before they even treat, they go in and get a preliminary mite count and see how many mites per 100 bees they have. And then after they're done with their treatments, to make sure they know that their treatments were effective, obviously we still recommend going in and doing mite counts to make sure that your treatment was, did have great efficacy and did knock down the mite population.
The before and after treatment test is pretty common, but testing exactly the same bees is kind of a new wrinkle that I like, and I'm wondering if beekeepers are doing that, and should more of them be doing that?
I don't know if specific beekeepers are doing it. I mean, I guess you could to show exactly the same, but I think that you're honestly going to see very similar results if you treat with, amitraz, and then you have very similar mite counts to before you treated. Then it should be fairly obvious that you are seeing some resistance to mite populations within those bees, within those colonies. So I think even if you're going through and you're not seeing that that amitraz is being that effective, I think that's having pretty much the same effect potentially as using the same bees.
To me, anyway, that brings up an interesting point that I'm going to look at a little more depth with my bees this year and see what happens. I don't use amitraz, but I can get some and see how it might work using exactly the same bees. I like that approach. When you get down and you're looking at this, you're finding bees that are resistant, very resistant. Will you be involved with them after this?
So that's what we're hoping to do, is that if we do find some bees with varroa mites that are resistant, and we have resistant populations of those mites, we're hoping to then be involved with the beekeeper in the future and look at different treatment methods that we can go through. And that's one of the great things, that they have great connections with commercial beekeepers down there, that if I think we're hoping to potentially design some studies working with them and seeing how we can manage those colonies with those resistant mite populations to try to get that resistance out of the population.
So it sounds like you're going to become a bee breeder.
I don't know about that so much, but
I think it's important work for IPM. If beekeepers are using the same treatment over and over and over, that's how you're going to find resistance. So I think it's also a great example of the research following beekeepers saying, hey, my treatment didn't work. And researchers looking closer to see if that's true and why, and how we can make that tool useful again and prolong its utility. We've been using amitraz for a long time, and we know that mites develop resistance, and we sure don't want to lose that tool.
Rogan, can I ask you a quick question?
Yeah.
I'm curious. Do you know if there's any relation between the viral load of varroa and this resistance, or is just like separate statements altogether?
That's actually a really great question. And I don't know if there's a connection, but that's definitely something that could be looked at. But I would assume that colonies with more resistant mites are going to show higher viral loads, because you're probably going to have more mites in the population. But I don't know if the resistant mites in particular do carry higher virus titers comparatively. But that's a really good idea.
I'll be willing to receive some of your varroa if you ever want to send me some.
Okay.
Well, Angela, you said you are very involved with the almond growers, and the Almond Board is a very forward-looking organization in my experience. Are you going to continue working with them on your project?
Yeah, hopefully, I would say. I know when I was interviewed for the scholarship, who called me? I forgot. But there's potential.
Christine Gemperling.
Yeah, Christine wanted to come visit the lab. So hopefully in the future, we can keep this collaboration going. I am fairly new to California. I was more used to beekeeping in a small scale back in Mexico, but this is huge, right? In California, it's just outstanding.
It's as big as it gets anywhere.
Yes, that's what I've heard.
Where you are, yeah. Well, what have we missed that you want to let people know about?
I just want to say that if you have the opportunity to support Project Apis M, please do. I'm very fortunate to be a 2-time recipient scholar from them. So one of their first scholarship that I was awarded, it's actually continues still helping me with my master's project, and actually allowed me to add a second piece onto my master's project to actually do some gene expression and hormone testing on some of my bees from that pesticide contaminated environment that I wouldn't have been able to do without their funding. So I'm very fortunate to receive some funding from them, and I hope that they continue to support me in the future.
Very cool.
Yes, very cool. Well, Rogan, congratulations. Angela, what have we missed that you want to share?
Well, I wanted to say that I'm very thankful. First of all, this is great funding for me and for the lab. And also that if anybody would like to connect with our lab or discuss anything scientific, I am really looking forward to forming this science, beekeeping, and farmer relationships in California. And as a native Spanish speaker, I just know I'm eager to get more involved in these conversations. And if anybody has doubts and I can clarify them, that will be great. Or if you can clarify all my doubts, that'll be excellent. But I'll be here in Davis for at least the next 3 years. So you can find me here. And that's it. Thank you for inviting.
To take this opportunity, both for Rogan and Angela and Danielle. All of their contact information is provided in our guest profiles found in the show notes on the podcast. So you want to check those out. Danielle, give you the closing comment spot.
I think these are two great examples of the kind of applied work that PAM wants to support. These are questions that beekeepers pay attention to, pesticides in almonds, and having more people doing good work at that Davis lab is so important. The almonds and the honeybee nexus right out there, we need more scientists looking at that system. We need to use that UC Davis lab and the USDA lab and grow that capacity and do great work out there. Pesticides are an endless source of questions and they change all the time. So this kind of work is really important. And with Rogan, the projects that he's working on and pesticides and also these Varroa questions, again, this is our applied interests in real time, investing in these students to be a resource for our whole industry. So we're excited. We're happy that you guys are doing this work. You're a great investment, and thank you for helping out the bees. We think it's a great program, and it's a fun part of my job to give you guys money and see you be so productive.
Well, Rogan and Angela, again, congratulations on these awards, and we wish you the best of luck in finding the answers you're looking for, because we all need them. And Danielle, thank you for Project APSM and all the good work you guys are doing. Keep it up, please, okay?
We'll do it. We intend to. We'll talk to these guys again when they make their publication.
Sounds perfect.
Good.
Yes, definitely.
Well, keep in touch. Well, thanks, everybody, for joining us today, and we'll be watching for those future papers.
Thanks for having us.
Thank you.
Kim, as I said, it's really fun and energizing to hear from the young researchers. It's an exciting program.
It is, and the work that they're doing is stuff we all need. They're answering questions we all have and don't have and need. I again salute PAM for the work that they're doing. The group of people that contribute to PAM certainly deserve attention also. All of the above hopefully are going to make life better for all of us.
I think the honeybee industry has some great organizations working on their behalf. We have PAM here, and we have Bee Informed Partnership, those two organizations in and of themselves. And then all the supporting organizations that feed into those are really doing fabulous work for the beekeeper and for the honeybees.
Probably, to me, the greatest thing about all of this is that it's our industry supporting our industry, as opposed to our handout to somebody else. Now, people are making contributions because they realize the value of our industry, but our industry is out there doing the legwork, finding the answers, and getting them applied. So it's a pretty neat group of people to be associated with.
It is. And I was sitting there listening to Angela, and I was thinking, listening to her talking about chasing and tracking down molecules, and we're talking about really small things in the wax, and then the bee larva tissue and the bee tissue. And at the same time this week, we had NASA hitting asteroids with rocket ships. We live in exciting times. You can go from one extreme to the other.
And I guess just be glad I'm not in Florida today.
All those people in Florida and our listeners.
I hope they did well. Or as well as could be expected.
Well, that about wraps it up for this episode. Before we go, I want to encourage our listeners to rate us 5 stars on Apple Podcasts, wherever you download and stream the show. Your vote helps other beekeepers find us quicker. Even better, write a review and let other beekeepers looking for a new podcast know what you like. You can get there directly from our website by clicking on reviews along the top of any web page. As always, we thank Bee Culture, the magazine for American beekeeping, for their continued support of Beekeeping Today podcast. We want to thank our regular episode sponsor, Global Patties. Check them out at globalpatties.com. Thanks to Strong Microbials for their support of this podcast. Check out their probiotic line at strongmicrobials.com. We want to thank Better Bee for their longtime support. Check out all their great beekeeping supplies at betterbee.com. Thanks to Northern Bee Books for their support of Bee Books Old New with Kim Flodham. Check out all of their books at northernbeebooks.co.uk. And finally, and most importantly, we want to thank you, the Beekeeping Today podcast listener, for joining us on the show. Feel free to leave us comments and questions at Leave a Comment section under each episode on the website. We'd love to hear from you. Thanks a lot, everybody.